Okay, folks, let's talk today about coastlines and oceans. So here we see a picture of a coastline. Doesn't look very much like North Carolina, does it? Not a particularly sandy coastline. It's pretty rocky. It's got these big sheer cliffs and big, huge waves hitting. We can see a little lighthouse off in the distance up there. Why is it that some coastlines are really rocky like this and other ones are sandy like they are in North Carolina? We're going to talk about a lot about that today. We will start this lecture by mentioning some types of coastlines. They are categorized in many different ways. Then we'll talk about waves and their effects, and tides, and storm surge. And finally, we'll talk about ocean basins and the sediment that gets deposited in them. Coastlines can be classified in a couple different ways. The ones that we're going to focus on in here are being classified by tectonic activity, right, plate tectonics, or by morphology, the way they look. So passive is a type that is related to the tectonic activity. So passive coastlines have little tectonic activity going on, or none. Whereas active coastlines have lots. Classified a different way, we can classify those same coastlines as being sandy or rocky. So that's pretty self-explanatory. Or occasionally we can add a sort of a subclassification called tropical, where we've got coral reefs nearby. Turns out these are pretty related to one another. The passive coastlines are usually sandy, and the active coastlines are usually rocky. That plate tectonics ends up pushing up a lot of things, right? So if you've got a convergent plate boundary, you might be lifting your coastline a little bit. There are other classification schemes, and we'll just briefly mention some of them that are related to what's happening with sea level, whether the land is moving outward, that's prograding, or whether the sea is moving inward, that's transgressing, or whether the coastlines are more dominated by tides or by waves, and that changes the way that they look. But that's sort of that's the next level of geoscientific thinking. We're going to start by just talking about tectonic activity and morphology, sandy or rocky. Passive coastlines, like this picture that I have back here, which is from Cape Cod in Massachusetts, these are not associated with present tectonic plate boundaries, right? So the east coast of the US is a good example because we don't have any current tectonic boundary there. The nearest tectonic boundary is off in the middle of the Atlantic Ocean. These coasts often have a very shallow slope, right? So the slope here is like that right there, that little wedge. And it's a very shallow slope as far as these things are concerned, certainly much less steep than those rocky cliffs that we saw before. And passive coastlines often have sandy shorelines, as we've mentioned. US East Coast is a good example. The Gulf Coast is another one that maybe you have some familiarity with. Both coastlines are shallow and largely sand covered. They'll often have barrier islands. So barrier islands are a big feature of coastlines nearby Tennessee. So North Carolina especially has this big network of barrier islands. And this picture from a helicopter or a plane, it actually looks like the ocean extends off in both directions here. Really, this way is the ocean, and that way is toward shore. It's a big bay or lagoon that we're crossing. I'm not sure exactly where Peel Island is, so I'm not sure what to call this this inland water. This is really shallow water, maybe up to a depth of about 20 feet. And you can just barely maybe make out the coastline off there in the distance, or at least where sea level finally meets the land that far away. This whole feature here is a barrier island. And you often find them on sandy coastlines or passive coastlines. Those two tend to overlap a lot. Here's an image, a Google Earth image of North Carolina, and you can see some more of these barrier islands here, or spits. Spits are very similar to a barrier island. It's just that they actually have a little bit of land connecting them to the barrier island itself. So a spit is actually connected to the land, whereas the barrier island, you need a boat or a bridge to get over there. So you have all of this is that system of barrier, spits, and island. And all this here is water. very shallow water. And the island separating them is that system of barrier islands. You'll also see, if you look offshore just a little bit, that a lot of the water in here is pretty shallow. That's called the continental shelf. It's still on continental crust, and it takes a long time if you're, taking a boat out there. This water is going to be maybe 100 meters deep at most for a while until you get to the shelf break there. But before that, these continental shelves are actually pretty wide on sandy coastlines, on passive coastlines. Hard to pull the two apart because they overlap so often. In contrast, active coastlines are associated with current plate tectonic boundaries. Often they are convergent boundaries, but not always. Like you see a lot of these cliffs near LA. This is a transform boundary, but still there was recent tectonic activity here. There was recent uplift caused by those same plate tectonic forces. And so you end up generating these cliffs. They're associated with mountain building events that are caused by the plate tectonic activity. They're also often associated with earthquakes and volcanoes because those boundaries are there. These are often very steep if you take it, right? You might have a little bit of a sandbar there, but then it's way steep to get up to the top of that, those cliffs. Active coastlines are often rocky. And so this would be a rocky coastline because it's got these rocky cliffs here. And so in general, the US West Coast is a really good example of that. You'll find beaches, but they're a little tougher to get down to. We need to do some engineering in order to get roads or parking lots down there for you to go and enjoy them. I will say that rocky coastlines are often, but not always, on active coastlines. And we have a good example of that in the US, so I wanted to point it out. This is actually a picture from the US East Coast, Acadia National Park in Maine. And the thing about Maine is that it is passive. There's no plate tectonic boundary nearby, but it does have a rocky coastline. And the reason for that is that there was uplift here for a different reason. The uplift really wasn't tectonic in origin, so it's not that there were plates colliding together, but instead what we call glacial rebound. So in this spot, there used to be maybe a whole mile of ice. In the recent past, a few tens of thousands of years ago, and that was pushing all the rocks so that all of these rocks were probably, 20, 30 feet lower than they are now, sitting at sea level, maybe even lower than that. As the ice melted, this rock started to rebound. Because there wasn't any more force pushing down on it, it started to rise slowly, even a little bit faster than sea level has risen since the ice melted. And as a result, those rocks are now sitting a decent bit above sea level today. So I just want to point out that rocky coastline isn't always active, but it is usually active. This is a pretty rare thing. Rocky coastlines often have what we call those wave-cut cliffs. So we saw the cliffs, but I didn't mention that they were wave-cut until now. And what happens is that, tides come up to about here, go down to about there. And when the tides are up here, the waves are smashing against these cliffs here in the wave attack zone, and they are undermining the cliff over time, right here. And so as they eat away, eventually that cliff will collapse and you'll get a bunch of rocky debris that forms down here. And some of it gets washed out to sea and some of it sit there. And then over time, you'll get it eaten back a little bit more and you'll undermine some more cliff. But those waves are always happening at roughly the same height and they're always undermining the cliff at roughly the same spot. So you end up generating these pretty steep cliffs that are supported by that rock that remains. And they collapse once the waves undermine them. Another feature is this wave cut platform, which is sort of the area between high and low tide, and the waves sort of as is a buzzsaw churning all this stuff up as they go. And that's, really where all of the erosive power of those waves is being concentrated along that wave cut platform. So you can see those if you take a look at some of these images. This area here would be the wave cut platform. Oftentimes, as I said, those cliffs are going to collapse and they're going to leave some rubble behind. And if the waves and tides don't manage to move most of that out, then often the collapse of that cliff face will leave a lot of rocky debris covering those wave cut platforms, but not always. For example, here in South Wales in the UK, here's a really good example where this solid rock is much flatter, much less rubble covered wave cut platform. Although of course you can still see a lot of rubble at the very base of the cliff still. But maybe because of the geology, this might be limestone or maybe some shale, hard to tell from back here. Because of that, those pieces are probably a little easier to smash up and move offshore. So you get rid of that a lot faster than you did this one, which was probably made of something like granite, a little slower to break down. At any rate, if you go and you see these big cliffs and you see these wave cut platforms, you're on a rocky coastline. And you can guess that you're probably on an active coastline. Turns out this is another example where it's passive here at the moment, but let's not worry about that. A lot of times, rocky coastlines are active coastlines. Here's an example from LA where it is a rocky coastline and it is an active coastline. And you will have a morphology sometimes that are called headlands and pocket beaches. So beaches make a pocket shape, and the headlands over here are the bits of rock that jut out into the water. And they often alternate in pretty close proximity. So here's another headland that's just being eaten away. Here's another pocket beach. Here's another headland. Back out here, there's probably a pocket beach hiding behind there in the image. And here's another headland. Their exact appearance is going to depend on the bedrock, but you will often see these on rocky coastlines. Some other features of rocky coastlines include sea caves and sea arches. The main thing is that weathering and erosion are generating these sea caves and sea arches, and they are exploiting points of weakness in the rock, either joints or faults in the rock that it's easy for the water to get in there and break it apart, or places where the lithology of the rock, the type of rock you're dealing with, is a little bit weaker. You know, maybe you've got some shale mixed in with some sandstone, and the sandstone is going to stand strong, but the shale is going to break down a little bit easier. So here you see the start of one of these, where you have a sea cave that's formed because all of this rock has been eaten away. Over time, if that happens often enough, you can end up generating sea arches instead, as the sea cave eats all the way through to the other side. If you manage to erode a lot of this, such that all this rock collapses, you'll still have this bit of rock sticking out over here, and that's what we call a sea stack. So you'll see a lot of these on several rocky coastlines, like this one in Australia, where these sea stacks used to be connected to the mainland, but they have been disconnected because of erosion that's happened in between. Here and here, and in between here and here. All of these places have been separated from the coastline by erosion, exploiting points of weakness in the rock. One more feature, I've mentioned that there were tropical coastlines that have reef systems. Reefs can be a range of distances from the shore, either tens of meters to sometimes several miles offshore, like is the case for a lot of the reefs in very southern Florida. But remember that the continental shelf is pretty flat on these on these passive coastlines. So really the water is not very deep where these reefs are forming, you know, maybe tens of feet deep at most. And they generally grow in warm waters, which is why they are features of tropical coastlines. And in these warm waters, where the water is pretty clear, coral reefs are able to build the reefs themselves. Really, it's sort of the scaffolding for their little bodies out of calcium carbonate. So these are sort of a sub-feature of passive coastlines. If they were active, we wouldn't have these really nice flat areas on which to build the reefs. You'd probably also have a lot more erosion of sediment on the beach, and so the water would not be very clear on those active coastlines. So you tend not to generate reefs very easily on those active coastlines. As I mentioned, there are a host of other classification schemes, and so here is sort of a summary of a couple of those, where left and right, as you see here, is tidal versus wave power, and how that shapes the coastline. So you have more barrier beaches and barrier islands where you have more waves, and where you have more tides, you might have tide-dominated estuaries. At least those are the cases for transgressive beaches, and this means that the sea level is rising, at least relative to shore. It's coming on shore. I would like you to know this word, transgressive. Sea level is rising, coming onshore. I would also like you to know this word, which is the opposite. Relative sea level is falling. But often that's not so much because the sea level is falling there as it is because sediment addition, you're getting so much sediment from the river systems that the river is actually, or that the land is actually moving out in this direction as sediment gets dumped along this. The added sediment pushes the shore out. I don't want you to have to remember all of these different things. And, you know, some of these morphologies are really complicated. We're not going to really talk about how these tidal, you know, the tidal flat forms versus the strand plane and things like that. But know that there are different ways to classify these beaches in a little more detail that are related to things like waves versus tides, or to things like whether sea level is rising or falling in a relative sense. Yeah, so you see there are a lot of different ways to categorize these coastlines. I want you to remember active versus passive, and sandy versus rocky, and some of the features you might see on each one. Things like barrier islands or sea stacks.